Hey, this is Dr. B, and let's talk about gravimetric analysis. Let's say you have an unknown solid. You'd like to know what it is. You dissolve it in water. You react it with something that forms a precipitate. These are oftentimes heavy metal salts, since they oftentimes form precipitates. And then you weigh that precipitate and back calculate what you must have started with. I'll go over the procedure and we'll solve a problem. So dissolve that substance in water, react it with a known substance, oftentimes a heavy metal salt, to form that precipitate. Filter it and dry it. If it's water, you need to be very cautious about doing that. You need to let it dry in an oven, typically overnight. Now, if you can get it to form a precipitate that's a gas, you don't have to go through that whole drying step. Be careful, however, that your gas does not dissolve much in water. And if it does, you have to subtract that out. You weigh that precipitate and use the amazing power of chemistry to figure out what that starting substance must have been. Let's solve a problem. A 0.5662 gram sample, I'm now just reading from the right here, of an ionic compound containing chloride ions and an unknown metal cation which we need to identify. In other words, is it sodium chloride? Is it lithium chloride? That's the kind of question you're trying to solve. So it has that unknown metal cation, it's dissolved in water, and it's treated with an excess of silver nitrate. That's our heavy metal salt. If 1.0882 grams of silver chloride precipitates, and it will, thus sucking up all those chloride ions, what is the percent by mass of chloride in the original compound, and identify the compound? So the strategy that we're going to use is to find the percent chloride that naturally exists in silver chloride, convert that to grams. That must have been the grams of chloride that were in the original sample. The rest must be that other metal cation. See those 2% and see what would be a nice match for that. So silver chloride always is 24.72% chloride by mass. And if that's true, and we had a 1.0882 gram sample, well, we know what the mass of chloride is. The mass of chloride is 0.2690 grams. Now, that's true for the precipitate that formed. It also must be true for the ionic compound that you started with, since all those chloride ions reacted. So we have a sample that is 0.5662 grams total, of which 0.269 grams are chloride. We should be able to find out the percent chloride by mass. That's 47%. Okay, so that's what they asked for. That's great. Now we need to know what it is, right? Well, you've got a salt that is 47.5% chloride. That means the metal cation is like 52.49%. And then I just grab a periodic table, and what I said to myself was, well, I know chlorine's 35.45 grams per mole. I need some cation that's just a little bit heavier than that. And if I don't get a good match, well, then I'll check out things where it's like calcium chloride, where I'd have 2 chlorides for every one cation. And I'd basically poke around, look for a match. There's not too many group 1 and group 2 cations to consider, and it's pretty unlikely it's going to be something else. And right away, you'll see that potassium chloride's a nice match. It checks in at, I think, 38 or 39 grams, and so it's a nice perfect match. That unknown sample is almost certainly potassium chloride. This is gravimetric analysis.